All right, let's get right into this. For a while now, the recipe for smarter AI has seemed pretty simple, right? Just get bigger models and throw more data at them. But what happens when we start to run out of that data? The entire field of AI is actually slamming into a massive roadblock. And today, we're going to break down a new scientific paper that might have just found a way around it.
Think of it like this. AI is running out of food. All that high-quality text from the internet, the very stuff that makes these models so smart, is actually becoming a scarce resource. But what if there was a new recipe? One that could create a basically infinite supply of new, high-quality AI food. That's what we're talking about today.
So this leads us to the heart of the problem. It's something researchers are calling the data wall. And it's the big mystery that the paper we're looking at, BeyondWeb, is trying to solve. So what is this wall exactly?
Well, the data wall is that point where we've pretty much scraped all the useful, good quality data from the internet. And when you hit this wall, just training your models for longer on the same old stuff doesn't really work anymore. You get less and less back for your effort. Progress just stalls. So the billion-dollar question becomes, how do you get over that wall?
Generally, people are trying two big strategies. The first one is generator-driven. This is where you use a massive AI, like a GPT-4, to just write brand new articles and textbooks completely from scratch. The second approach, and this is what we're going to focus on, is called source rephrasing. Here you take existing web data and you use another AI to intelligently remix, reformat, and improve it, kind of like a super smart editor.
And this is exactly where the paper introduces its big idea, a new framework for source rephrasing that they call BeyondWeb. The researchers behind it are saying this is a huge step forward, maybe even a whole new frontier for how we train AI. And let me tell you, they are not exaggerating about the results. What they discovered is that a smaller, way more efficient model trained on this cleverly crafted data could do something that honestly sounds kind of impossible.
Okay, now check this out, because this is wild. What you're seeing here is a 3 billion parameter model, the smaller one, trained on BeyondWeb data, and it is outperforming a much larger 8 billion parameter model trained on a different synthetic dataset. Look at those scores, 60.8 for the little guy versus 58.6 for the big one. This is a huge deal. It proves that the quality and the smarts of your data can actually be more important than the raw size of your model.
And the efficiency gains are just wow. The paper found that to get to the same level of performance, training with this BeyondWeb data is up to 7.7 times faster than using standard web data. In the world of AI, where training can take weeks and cost a fortune, that is an absolute game changer.
All right, so this all sounds amazing, but how? How does it actually work? Let's pop the hood and crack the code. We're going to walk through the key questions the researchers asked to figure out exactly why BeyondWeb is so darn effective. First things first, they had to ask the most fundamental question of all. Is this synthetic data thing for real? Can it actually break us through the data wall, or is it just a temporary fix?
I love this chart because it's so clear. The gray bar, that's what happens if you just repeat the data you have. You get a score of 45.5. The light blue bar, that's the theoretical limit if you could find more high-quality natural data. That gets you to 46.2. But now, look at BeyondWeb in dark blue. It scores a 50.4. It completely smashes through that supposed limit. So the answer is a huge resounding yes. It's not just about creating more data. It's about creating smarter data. That's how you break through the wall.
Okay, so that's a massive finding, but it immediately brings up another question, right? If we're just rephrasing existing data, do the ingredients we start with actually matter? I mean, do we need to start with high-quality sources, or can we just take junk from the web and polish it up?
And the answer couldn't be clearer. Quality in means better quality out. Rephrasing high-quality web data gives you a noticeable accuracy boost compared to starting with the low-quality stuff. It's not a night-and-day difference, but it absolutely proves that your starting point matters.
All right, so let's dig into the next part of this. We know starting with quality data helps, but what are the other secret ingredients in this recipe? What are the actual techniques that make this synthetic data work so well?
This brings us to a really critical ingredient, diversity. When you're creating mountains of this new data, does the variety of it matter, or can you just use one simple trick, like turning everything into a question and answer format over and over and over again?
So the paper found something super interesting.
If you use just one single repetitive strategy, it works great at first. The model learns the new format really fast, and you see a nice little bump in performance. But after a while, that learning curve just flattens out. The model pretty much gets bored and just stops improving.
But, and this is the key, when you use a bunch of different generation strategies, things like summaries, Q&As, dialogues, step-by-step explanations, and so on, the model keeps on learning. That diversity is what gives it a sustained signal for improvement. It prevents that plateau and leads to way better performance in the long run.
Okay, final big question in our investigation. What about the tool you use to make the data? Does the AI that does the rephrasing, the generator, need to be some massive, super expensive, state-of-the-art model? Is this a technique only a few giant tech companies can afford?
The results you're seeing here are actually really promising news for everybody. Yeah, a bigger generator is a little bit better, but look at the jump from a 1 billion to a 3 billion parameter model. That's a pretty good leap. Now look at the jump from 3 billion to 8 billion. See? It's tiny. This tells us you hit a point of diminishing returns really fast, and that a relatively small 3 billion parameter model can do a fantastic job. This whole technique is way more accessible than you might think.
So, let's pull all these threads together. After all this investigation, what's the final verdict? What does this all mean for the future of AI?
The paper really boils it all down to 3 key principles. First, prioritize quality. Simple. Start with good ingredients. Second, you have to align the style. This is crucial. It means if you want an AI that's a great chatbot, you need to train it on data that looks and feels like a conversation. Your synthetic data has to match what you'll use it for. And third, maintain diversity. Mix it up. Use lots of different styles to keep the model engaged and learning.
And that's really the ultimate takeaway here. There's no simple trick or magic silver bullet. Generating synthetic data that actually works is a science. It takes careful planning, thoughtful experimentation, and a deep understanding of how all these different pieces fit together.
You know, this is exactly the kind of cutting-edge science we love to break down here on VibeDoc. So if you want to understand the next big breakthroughs in AI and other fields, do us a favor and hit that subscribe button. That way you won't miss our next explainer.
And this all leaves us with one last really provocative thought to chew on. If we can so carefully control and craft the data an AI learns from, could this be the key to not just making AI smarter, but to building models that are aligned with human values right from the very beginning? It's a really powerful idea to think about. Thanks so much for joining me.